section 9.2 on similar polygons. We're going to determine whether each pair of polygons is similar. These first two are pretty standard. You need to check to see if the corresponding angles are congruent. Also, you need to see if the corresponding sides are proportional. So if you got 4 sides, you need to check 4 pairs of angles, and you need to check 4 ratios. These ones that overlap, these ones are a little more interesting than these ones that are separated. So we're going to do these two together. This small figure is a rectangle. There's 4 right angles. The big figure is a rectangle because there's 4 right angles. So the corresponding angles are congruent. The next thing you got to do is check the ratios of the corresponding sides. So we're going to compare the smallest side on the small figure with the smallest side on the bigger figure. So 4 goes with 8. Then I'm going to compare the biggest side on the small figure with the biggest side on the biggest figure. Does 4/8 equal 8/12? I think a lot of you probably know that answer already. 4/8 is 1/2 clearly. 8/12, definitely not 1/2. These are not equal. So if those side lengths are not equal, the side lengths are not proportional. So these are not similar because the sides are not proportional. Number 4, we have a triangle inside of a triangle. Let's see if those 2 triangles are similar. Well, the first thing you got to do is check the corresponding angles. We got to check to make sure there's 3 pairs that are congruent. We got 1 pair of right angles, so that's 1. We got 1 pair of angles that have 2 arcs on them, so that's 2 pairs. And then we have this angle C. It's actually on both triangles. So the corresponding angles are congruent here. The next thing you got to do is check the ratios of the corresponding sides. So I'm going to look at my small triangle, and I'm going to notice that it's a right triangle. I have a short leg, a 12, and a 13. Something 12, 13. Remember your Pythagorean triples, 5, 12, 13. Now we're going to compare that 5, 12, and 13 with the corresponding sides on this bigger triangle. So the smallest side on this big right triangle is 24. It's not 24. This 24 goes with that 12. The biggest side, or the hypotenuse, is 26. If you multiply 5, 12, 13 by 2, you get 10, 24, 26. So that tells you right there that your ratio there is 1 to 2. These are all equal. So yes, they're similar. The 3 ratios equal 1/2, so that's your similarity ratio, and the 3 corresponding angle pairs are congruent. Next section. In the figure below, they give you 2 trapezoids. Trapezoid ABCD is similar to trapezoid EFGH. Use this information to answer the questions. So if you have 2 similar trapezoids, you know 8 things. Let's list all pairs of corresponding angles. Then we're going to write the 4 ratios that relate the corresponding sides. Those are your 8 things that you're listing. So all pairs of corresponding angles. Angle A is going to go with angle E. So I'm going to write it like that because angle A is congruent to angle E. Now you could also say angle A is congruent to angle H, and you're not wrong, but does angle A correspond with angle H? It doesn't. So that's why we did it this way. Angle B is congruent to angle F because they correspond. I'm looking at the statement, not necessarily the picture. Angle C is congruent to angle G. Angle D is congruent to angle H. Those are 4 things that I know about the angles. The 4 things that I know about the sides, I'm going to write my ratios that have the corresponding side lengths. So segment AB goes with segment EF. So the top does go with the top. So I'm going to write 8 to 12. And I know that has to equal the other ratios. So if this is 8/12, the rest of them have to be 8/12, but we're going to use different numbers. Segment BC goes with segment FG. So that's 5 and Z. Segment CD goes with segment GH. So 11 goes with Y. And then the last one, segment AD goes with segment EH. So X goes with 6. Number 7, we're going to write a proportion to find the missing measure for X, then find the value of it. So we need to find X. We know that ratio is going to be 8/12. All right, now I know that 8/12 is the same thing as 2/3. So I'm going to write this ratio. 2/3 equals X over 6. And in doing that, I made my job easier because I'm multiplying with smaller numbers. Also, I noticed that 3 goes into 6 twice. So 3 times 2 is 6. 2 times 2 is 4. I didn't even need to cross multiply. Write a proportion to find the missing measure for Y. So I know my scale factor or similarity ratio is 2/3, so I'm using it again. That's the same thing as 11 to Y. Now I can do the same strategy here. I know that 2 times 5.5 gives me 11. 3 times 5.5 I probably don't know, but I can figure it out. 3 times 5.5 gives you 16.5. And you could have just used the standard multiply 3 times 11 then divide by 2. Actually, that probably would have been easier. You probably would have been able to do that in your head a little bit quicker. But that way's fine too. It's nice to know other ways to do it, depending on how the problem's set up. Number 9, write a proportion to find the missing measure for Z. So my ratio that has the Z is 5 to Z. I know that has to be 2 to 3. Right? So again, I could have done 2 times 2.5 gives me 5. But I think it's easier to take 5 times 3 is 15. 15 divided by 2 is 7.5.